Welcome to this tutorial on simulating an equilibrium reactor in DWSim. In this tutorial, we will learn to define an equilibrium reaction, simulate an equilibrium reactor, calculate conversion percentage and reaction extent. To record this tutorial, I am using DWSim 5.2 Classic UI Update 22 and Windows 10. The process demonstrated in this tutorial is identical in other OS also, such as Linux, Mac OS X or Fossey OS on ARM. To practice this tutorial, you should know to add components to a flowsheet, select thermodynamic packages, add material and energy streams and specify their properties. The prerequisite tutorials are mentioned on our website. You can access these tutorials and all the associated files from this site. We will develop a flowsheet to determine the exit composition from an equilibrium reactor. Here we give reaction and inlet stream conditions. Here we give property package and reaction temperature. I have already opened DWSim on my machine. Go to File menu and select New Steady State Simulation. Simulation Configuration Wizard window appears. Click on the Next button at the bottom. In the Compound Search tab, type carbon monoxide. Select carbon monoxide from ChemSafe database. Similarly, add water. Similarly, add hydrogen. Next, add carbon dioxide. And then, at the bottom, click on the Next button. The Property Packages opens. From Available Property Packages list, double-click on Routes Law. Then, click on the Next button. We will move to a new window named Flash Algorithm. From Default Flash Algorithm, select Nested Loops VLE. Click on the Next button. The next option is System of Units. Under System of Units, we will select C5. Then, at the bottom, click on the Finish button. Let us now maximize the simulation window. Now, let's insert a feed stream that enters the equilibrium reactor. On the right-hand side of the main simulation window, go to Flowsheet Objects. In the Filter List tab, type Material Stream. From the displayed list, drag and drop a material stream to the flowsheet. Let's change the name of this stream to Feed. Now, we will specify the feed stream properties. Go to Input Data. Under Stream Conditions tab, select Flash Spec as Temperature and Pressure if not already selected. By default, temperature and pressure are already selected as Flash Spec. Change temperature to 25 degrees centigrade and press Enter. Change pressure to 1.01325 bar and press Enter. Change mass flow to 3600 kg per hour and press Enter. Now, let us specify the feed stream compositions. Under Input Data, click on Compound Amounts tab. Choose the basis as mole fractions if not already selected. By default, mole fractions is selected as basis. Now, for carbon monoxide, enter the amount as 0.5 and press Enter. For water, type 0.5 and press Enter. For hydrogen, type 0 and press Enter. Similarly, for carbon dioxide, type 0 and press Enter. At the bottom, click on Commit New Values button. Next, we will define the equilibrium reaction. Under Tools, Click on Reactions Manager. Chemical Reactions Manager window opens. Under Chemical Reactions tab, click on the green colored Add Reaction button. Then click on Equilibrium. Add New Equilibrium Reaction window opens. Under Identification, enter the name as Water-Gas Shift Reaction. Let's enter the description. Reaction of carbon monoxide and water vapor to form carbon dioxide and hydrogen. Next part is a table of components and stoichiometry. The first column, name, shows the available components here. The second column corresponds to its molar weight. The next column is include. Under include, check all the check boxes. The fourth column is BC. Under BC, check the carbon monoxide checkbox, as conversion is defined in terms of carbon monoxide. Next column is stoichiometric coefficients. Under stoichiometric coefficients column, enter -1 for carbon monoxide, -1 for water, 1 for hydrogen, and 1 for carbon dioxide. Then press enter. In the stoichiometry field, we can see it shows OK. It means the reaction is balanced after entering the stoichiometric coefficients. Here the equation field shows the reaction equation. Then comes equilibrium reaction parameters. The basis is already selected as fugacity. Select phase as vapor. Now go to equilibrium constant. In an equilibrium reaction, the equilibrium constant can be defined in three different ways. First is Gibbs energy of reaction. If the equilibrium constant is unknown, it is calculated directly from Gibbs energy of reaction. Second is T function. Here, the equilibrium constant can be defined as a function of temperature. It is in the form of ln KEQ f of t. Third is constant value, where the equilibrium constant is defined directly. Here, we don't know the equilibrium constant directly or as a function of temperature. So, we will let it calculate from the Gibbs energy of reaction. Select Calculate from Gibbs energy of reaction. Click on OK at the bottom. And then close the Chemical Reactions Manager window. Now, let us insert an equilibrium reactor to the flowsheet. Go to Flowsheet Objects. In the Filter List tab, type Equilibrium Reactor. Drag and drop Equilibrium Reactor to the flowsheet. Let us arrange it as required. Next, name the reactor as Equilibrium Reactor. Now, let's insert two more material streams that exit the equilibrium reactor. To do that, let us drag one material stream to the flowsheet. Let us now arrange it. We will leave that stream as unspecified. Then, we will change the name of this stream to vapor product. Next, we will insert another material stream. Let us once again arrange it. Leave that stream as unspecified and name this stream as liquid product. Next, we will insert one energy stream and name this stream as energy. We are now ready to specify the equilibrium reactor, so let's click on it. On the left, we can see a tab displaying properties related to the equilibrium reactor. Under Connections, click on the drop-down against Inlet Stream and select Feed. Next, click on the drop-down against Outlet Stream 1 and select Vapor Product. Next, click on the drop-down against Outlet Stream 2 and select liquid product. Next, click on the drop-down against Energy Stream and select Energy. Now, we will go to the next section, Calculation Parameters. Here, the first option is Reaction Set. The option is selected as Default Set. Next, click on the drop-down against Calculation Mode. Select Define Outlet Temperature. Enter 225 degrees centigrade against outlet temperature. Now, we will run the simulation. So, click on the Solve Flowsheet button on the toolbar. Once the calculations are completed, click on the Equilibrium Reactor in the flowsheet. Go to the Property Editor window of the Equilibrium Reactor. Locate Results section. Under Reactions tab, check extent. It is 20.043. This is the extent of the water-gas shift reaction at 225 degrees centigrade. Now, go to the Conversions tab. We will look into the individual conversions of all the reactants. Here, for carbon monoxide, the conversion is 92.2478%, and for water, it is 92.2478%. Now, go to Insert menu and select Master Property Table. Double-click on the Master Property Table. Configure Master Property Table window opens. Enter name as Stream-wise Results Equilibrium Reactor. Enter object type as Material Stream. By default, Material Stream is already selected, so we will not change it. Under Properties to display, select object as Feed, Vapor Product and Liquid Product. Under Property, scroll down to see all the parameters. Now select the properties as Temperature, Pressure, Mass Flow, Molar Flow, Molar Flow Mixture, Carbon Monoxide, Mass Flow Mixture, Carbon Monoxide, Molar Flow Mixture, Water, Mass Flow Mixture, Water, Molar Flow Mixture, Hydrogen, Mass Flow Mixture, Hydrogen, Molar Flow Mixture, Carbon Dioxide, and Mass Flow Mixture, Carbon Dioxide. Let's close this window. Move the Master Property Table for better visibility. Here we can see the corresponding results for Vapor Product, Liquid Product, and Feed. The reaction is a vapor phase reaction, so we can see that liquid product stream shows zero flow rate and composition. Let's summarize. In this tutorial, we have learned to define an equilibrium reaction, simulate an equilibrium reactor, calculate conversion percentage and reaction extent. As an assignment, repeat this simulation with different compounds and thermodynamics, different feed conditions, different calculation parameters. Was the video available at the following link? It summarizes the spoken tutorial project. The spoken tutorial project team conduct workshops and give certificates. For more details, please write to us. Please post your time queries in this forum. The FOSSEE team coordinates conversion of existing flowsheets into DWSIM. We give honorarium and certificates. For more details, please visit this site. The FOSSEE team coordinates coding of solved examples of popular books. We give honorarium and certificates. For more details, please visit this site. The FOSSEE team helps migrate commercial simulator labs to DWSIM. We give honorarium and certificates. For more details, please visit this site. Spoken tutorial and FOSSEE projects are funded by NMAICT, MHRD, Government of India. This tutorial is contributed by Kaushik Datta and Priyam Nayak. Thanks for joining.